Good morning, dear students. See, in the last class, we were studying about the decision tree induction classification technique. Okay, so till now we have seen what is a decision tree. Okay, and also we have seen one of the example that is for constructing a decision tree. So with the help of Hunt's algorithm that we have seen. Okay, so apart from that, we were studying about the design issues that we need to consider while building a decision tree. Okay, so in that I had told that we need to consider two issues here whenever we are designing or constructing a decision tree here. So one is about how to split the training records here. So about that we need to take care of. See, at each step of the decision tree algorithm, we will be splitting the records into purer subsets here. So we will be choosing one of the attribute as a test condition. Okay, so in order to determine that test condition, see, we have got some of the methods here. So one method is based on the type of attribute. Okay, so based on the type of attribute also, we can specify the test condition here. And one more thing is, see here in the first issue, we also need to consider some of the evaluation measures here. So in order to check whether the test condition that we have chosen is good or not. Okay, so we must have the evaluation measures to find the goodness of these test conditions. So this is the first issue, that is we need to decide on which is the splitting attribute that we will be choosing, or which one we will be considering as a test condition here in order to divide or partition the training records. Okay, so based on the attribute type, we can choose the that is test condition here. That is the first thing that we can do. And for specifying the test condition, again, we have got the different that is methods here. Like as I explained, see, based on the type of that is attribute, that is whether it is a binary attribute or nominal, ordinal, okay, or it is a continuous attribute. So based on that, we can specify the test condition, or one more method is based on the number of splits, whether it is a binary partition or multi-way partition or splitting. So based on that also we can specify the attribute test condition. Okay, so this is the first thing that we have discussed. Okay, that is the method to specify the test condition, or the attribute test condition here. So based on the number, that is the type of attribute that we have specified the test condition here. Okay, so one more thing that we need to consider here in the first issue is, that is, once we decide on the test condition, see how we can say that it is a good test condition or not. Okay, whether it is a correct test attribute or a condition to divide the attributes or not. So we need some measures here for selecting, or in order to measure the goodness of these test conditions. So that we will be studying in today's class, that is measures for selecting the best split. Okay, so here, see, we have got many measures so that we can use in order to select the best that is split, or in order to divide the training records into purer subsets here. So these measures actually they are going to depend on the that is number of records that belong to a class here. Okay, so based on the number of classes or fraction of records that belong to a class, say that is before and after splitting. So based on that, see, we will be defining these measures here. So these measures are defined in terms of the class distribution of the records before and after splitting. That is how many number of records belong to each class. That class distribution, based on that, that is before and after splitting, we will be defining the measures here. Okay, so for example, see, if you have got a fraction of records that belong to class I, see, for the given node T, see if it is denoted by P of I conditioned on T. See, this P of I conditioned on T is nothing but it is the number of records, fraction of records that belong to this class I. Okay, that is at the given node T. So now in case of two class problem, okay, so if you have got two classes to be assigned, okay, then in that two class problem, see the node distribution, see, it can be denoted by two fractions or the probabilities here, that is P naught and P1. So here P naught is nothing but it is the number of that is records that belong to the class 0, and P1 is nothing but the number of records that belong to the class 1. Okay, so now this P1, see, if you consider any two class distribution problem, see, in that P1 value will be equal to 1 minus P naught. Okay, if we consider 1 minus P naught, so that will be equal to P1. Okay, so in any two class problem. So if you consider, see the distribution of the records to these among these two classes, say it will be denoted by P naught and P1, P naught comma P1. So this P naught, say it is nothing but the number of records or the fraction of records that belong to the class 0, and P1 is nothing but number of records or fraction of records that belong to the class 1. Okay, so this P1 will be equal to 1 minus P0. So for example, say if we consider the that is distribution of the records based on the gender. Okay, so before splitting, see normally the both records probability or distribution will be 0.5, 0.5. That is before that is distribution or splitting of these records. See the fraction of the records, okay, that belong to each of the classes, that will be equal to 0.5 and 0.5. That is, we will assume that we have got the number of records. Okay, those number of records are equal. Distribution of records is equal. 0.5, 0.5 means that 50% of records belong to both the that is classes here, male and female. Okay. So now after performing the splitting here, so see here, after performing the splitting based on the gender attribute, see then the number of records that will be belonging to the nodes will be based on the actual that is the occurrence here. So for the class male, okay, so if you see here, so that is for the gender attribute. See the distribution will be for class 0, it will be 6, and for class 1, that is C1, it will be 4, that is 0.6 and 0.4. So in the same way, for the female, that is attribute, gender attribute. So the number of records that belong to the class 0 is 4, and number of records that belong to class 1 is 6. Okay, that is, we have divided the records by selecting this gender attribute. So initially we will assume that there are equal number of records that belong to each of these classes, but after selecting one of the attribute here for division or distribution, so then we will be able to correctly divide them. So if you observe here, see for the splitting, that is attribute gender for male, see number of records that belong to the class 0 is 6, and for the class 1 it is 4. So in the same way, see for the female, see for class 0 it is 4, and for class 1 it is 6. Okay, so in the same way we have seen the multi-way distribution or splitting of the test training records here. See for the car type, so if the car type is family or sports or luxury, so based on that, so again we have assigned the records, training records to one of the classes here for C0 and C1. Okay, so this is the distribution word, that is for C0, see total number of records that belong is 1, and for C1 it is 3. So like that for sports car, see total number of records that belong to the class C0 is 8, and for C1 it is 0. So based on the car type attribute also we have divided the records here. And one more is that is based on customer ID. So whether this customer ID belongs to the class 0 or class 1. So based on the customer ID we have divided the records here. So these are the different ways see in which we can that is assign the records to the different class levels. Okay, so we have performed the splitting here based on the attribute. Okay, so now the thing is, see once we assign the records, we must be able to measure the that is goodness of these splitting or the distribution. So we have got some of the measures here, so that we can use in order to measure the goodness of these splits. Okay, so these measures, they are actually based on the degree of impurity of the child node here. So some of the impurity measures or the measures that we will be using in order to measure the that is goodness of the split is, one is entropy. Okay, second one is Gini, it is also called as Gini index, and third one is classification error. Okay, so these measures are nothing but see now the thing is, see we have divided the attributes, records here. So I need to check whether my division or distribution is correct or not. So for measuring that goodness, see we have got some of the measures here. So these measures are based on the degree of impurity. So degree of impurity, see based on that, we have got some of the impurity measures here. So one is entropy, and second one is Gini index, and third one is the classification error. Okay. So this entropy equation is entropy of the record T. So it will be equal to minus summation of I is equal to 0 to C minus 1 P of I conditioned on T into log of P of I conditioned on T to the base 2. Okay, so I'll explain you with the help of example. Okay, in the next topic. So next one is Gini index. So Gini index of t is equal to 1 minus summation of I is equal to 0 to c minus 1 p of I conditioned on t whole square. That is, this p of I conditioned on t is nothing but it is the fraction of records that belong to the that is class I at this node t. Okay, and this c is nothing but it is the total number of class labels available. Okay, so in the same way, classification error of t at the node t, so it is equal to 1 minus maximum of that is fraction of records. So we will be considering the maximum of fraction of records, and that will be subtracted one from one. We will be getting the classification error here. Okay. So here this C is nothing but, as I said, it is the number of classes or the class levels. And if we consider the big of log of 0 to the base 2, so we'll get the value as 0 here. Okay. So now let's see one example. See, this is the given node, that is N1, N2, and N3. See, for these nodes, I need to find the degree of impurities of these measures. So I need to find the value of impurity measures here, that is Gini index and then entropy and the classification error. Okay. So you need to remember these formulas here. So that is entropy formula is minus summation of I is equal to 0 to c minus 1 p of I condition on t log of p of I condition on t to the base 2, and Gini index is 1 minus summation of c I is equal to 0 to c minus 1 p of I condition on t whole square, and classification error is 1 minus max of p of I condition on t. Okay. So now let's see these. Okay, so let us find the measures of these impurity for the node n1 first. See, Gini index says 1 minus summation of I is equal to 0 to c minus 1 p of I condition on t. So this summation, see here we have got only two classes here. So 2 means this I value, see, it will be varying from 0 to c minus 1 means 2 minus 1. So 0 to 1. So 0 to 1 means there will be two terms in this summation. So 1 minus, so here the term is P of I condition on T whole square. That is the fraction of records that belong to the class I at this node T. So the first class, that is class 0, see the number of records that belong to this class 0 is 0. Okay, so out of 6 records, so square I need to consider. Okay, this is the first term in the summation, so it will become minus here. So since there is minus here, so 1 minus 0 by 6 whole square is nothing but it is P of I condition on T whole square. That is for I is equal to 0, that is for the first term. See, the number of records that belong to class 0 is 0 out of 6 records is 0 by 6 whole square minus. So second term is, that is for I is equal to 1. That is how many records that belong to the class 1. So 6 records out of 6 records, they belong to the class 2, so square. So that is P of I condition on T whole square. So this is 6 by 6 whole square. So this first term we will get by considering the square of the fraction of records that belong to the class 0. That is 0 records out of 6 records belong to the class 0. So 0 by 6 square minus 6 records out of these 6 records, they belong to the class 1. So 6 by 6 square. So 1 minus 0 minus 1 is 0. So Gini index value is 0. Next, if we come to the entropy, see, entropy is minus summation of I is equal to 0 to c minus 1 p of I condition on t log of p of I condition on t to the base 2. So see here again, this is a summation. So I is equal to 0 to c minus 1 means, since there are two classes here, 2 minus 1. So I is equal to 0 to 1 means there will be two terms in this summation. That is for I is equal to 0 and I is equal to 1. Okay. So if we find this term for I is equal to 0, it is the fraction of records that belong to the class 0 into log of fraction of records that belong to the class 0. Okay, so that is minus of the fraction of records that belong to class 0 is 0 by 6 into log of fraction of records that belong to class 0 is 0 by 6 to the base 2. Minus second term is the fraction of records, that is I, for I is equal to 1, it is fraction of records that belong to class 1. So fraction of records that belong to class 1 is, that is 6 by 6 into log of 6 by 6 to the base 2. So now if we find this value, we'll get the value as 0. Okay, next third one is classification error. So classification error value is 1 minus max of P condition on T. So maximum of, that is fraction of records for both the classes we need to consider. So 1 minus maximum of, see, fraction of records is for class 0 it is 0 by 6 and for class 1 it is 6 by 6. Okay, so 1 minus maximum of this is 6 by 6. So 6 by 6 means 1. So 1 minus 1 is 0. So the values of Gini index and then entropy and then classification error is 0 at the node n. So in the same way, if we calculate the Gini index, entropy and the classification error for the node n2, see again formula is same, that is 1 minus summation of I is equal to 0 to c minus 1 p of I condition on t whole square. So for the class 0, see 1 minus, see fraction of records that belong to class 0 is 1 year. So 1 out of 6 records, they belong to class 0 year. So 1 by 6 square minus, so the number of records, fraction of records that belong to the class 1 is 5 out of 6. So 5 by 6 square. So if you find this value, you'll get the value as 0.278. Next, in the same way, entropy is nothing but minus summation of I is equal to 0 to c minus 1 p of I condition on t log of p of I condition on t to the base 2. So again, since we are having two classes here, so I value will be varying from 0 to 2 minus 1 means 1. So there will be two terms here. So we need to consider minus of fraction of records that belong to class 0 is 1 by 6 into log of that fraction. So log of 1 by 6 to the base 2 minus next fraction of records that belong to class 1 is 5. So 5 by 6 into log of 5 by 6. So once you evaluate this value, you'll get the value as 0.650. In the same way, classification error is 1 minus max of the fraction of records. So fraction of records that belong to class 0 is 1 by 6 and fraction of records that belong to class 1 is, it is 5 by 6. Okay. So total number of records is 6 here. Don't consider it as 1 and 5 here. Total number of records, if you consider 1 plus 5 is 6. So out of that, one number of records belong to class 0. So it is 1 by 6. In the same way, 5 records belong to class 1. So 5 by 6. So 1 minus max of this is, so you'll get the value as, I guess, it will be 1 by 6, I think. Okay, so just try to calculate that using calc. So you'll get the value. So if you subtract that, you'll get the value as 0.167. Okay. Next, in the same way for node N3, we will calculate the Gini index and entropy and classification error using the same formula. So again, see here, Gini index is 1 minus summation of I is equal to 0 to c minus 1 p of I condition on t whole square. So 1 minus, say fraction of records that belong to class 0 is 3 out of 6 records. So 3 by 6 square minus fraction of records that belong to class 1 is, again it is 3 out of 6. So 3 by 6 square. So simplify this, you'll get the value as 0.5. Next, entropy value is, see it is entropy is minus summation of I is equal to 0 to c minus 1 p of I condition on t log of p condition on t to the base 2. So again, since the record class levels are 2 here, I will be varying from 0 to 1. So two terms will be there. So the fraction of records that belong to the first class is 3 by 6 minus 3 by 6 into log of that fraction of records to the base 2. So 3 by 6 to the base 2 minus fraction of records that belong to class 1 is 3 by 6 into log of 3 by 6 to the base 2. Okay, so once you simplify it, you'll get the value as 1. And next, classification error is 1 minus max of the fraction of records. So max of fraction of records is 3 by 6 comma 3 by 6. So max again is, since it is same, so you'll get the value as 3 by 6. So 1 minus 3 by 6 is nothing but 0.5. Okay, so these are the different that is impurity measures that we have calculated at 3 nodes here. Okay, so once we calculate, see we need to determine which node has got the lowest impurity. Lowest impurity means the node which has got these less values, okay, lower values, that will be considered as the node with the lowest impurity. So among these nodes, if you observe, see the Gini index, entropy, and the classification error value is less compared to that is node N2. So N1 node has got the lower values compared to N2 node, and N2 node has got the lower values compared to the N3 node. So this is the sequence. Okay, so where we have found the different measure values. Okay, so here among these nodes, see the node N1 has got the lowest impurity because it has got the lowest values. That is followed by node N1, and then that is followed by node N2. Okay. So once we determine this, see next thing is, see we need to determine this how this test condition is going to perform. So in order to do that, we need to compare the degree of impurity of the parent node with the degree of impurity of the child node. So once we determine the impurity measures, see next thing is, see we need to decide on the how this test condition is going to perform. So in order to decide that, we need to compare the degree of impurity of the parent node with the degree of impurity of the child node. So if this difference which you're considering here, that is the difference between the degree of impurity of the parent node and the child node. Okay, so if it is more or larger, okay, if the distance difference is larger, then it will be considered as better test condition. So once we determine the test condition, next thing is, say we need to determine, see how well this test condition is going to perform. So in order to test the performance of this test condition, we need to compare the degree of impurity of the parent node with the degree of impurity of the child node. Okay, so we'll consider the difference among these two values. The difference is larger. If the difference is larger, then it will be considered as a better test condition. Okay. So now in order to that is determine the difference here. So see here we have got this equation I of parent minus summation of j is equal to 1 to k n of vj divided by n I of vj. Okay, so this is the that is delta equation. Okay, that is going to determine the difference between the degree of impurity of the parent node and the child node. Okay, so here this I of parent and then I of vj, so it is the impurity measure of the given node. Okay, and n is the total number of records here at the parent node, and k is the number of attribute values. Okay, so now coming to the algorithm for the decision tree induction. Okay, so already we have followed the method for constructing the decision tree using the, that is Hunt's algorithm. Okay, so now let's see one of the algorithms. See, again, it will be following the same method that we have studied for the Hunt's algorithm. Okay, so this is the skeleton of this algorithm, that is algorithm for the decision tree induction algorithm. Okay, so the name of the algorithm is tree growth. Okay, so this algorithm is used to grow the tree, that is the decision tree here. So, and tree growth is the name of the algorithm, and E and F are the, see, number of that is training records, and F is the attribute set here. So E is the number of training records here, or it is a training set record, and then F is the number of attributes here. Okay. So as I said, see, if all the records in the training record, okay, or training set, if they belong to the same class, so at that time we will be creating a leaf node, and we will label the majority class as the class label of the training records. So as I explained while explaining the Hunt's algorithm. So here, so see here, same things we have mentioned in the form of steps here. If the stopping condition of E comma F, if it is equal to true, see, stopping condition we will be arriving at, see, whenever the records they belong to the same class or to the same attribute values. If all the records, see, if they belong to the same class label or if they belong to the same attribute value, then using this stopping condition function, okay, this stopping condition function, it takes two parameters here, that is the input of that algorithm, E and F. E is nothing but the set of training records, and F is the set of attributes here. So if this stopping condition is reached, if it is true, so when we are going to reach stopping condition, once all the records they belong to the same class level or the attribute value. If they belong to the same class level or the attribute value, then it means that we have reached at the stopping condition. So if it is true, then we will be creating a leaf node here using this by calling this function, that is create node. Okay, so we'll be creating a leaf node, and then we will assign the that is class label as the majority class that will be appearing in the training records. So majority class, whether it is yes or no, so that will be choosing, and that will be assigned to the class label of this leaf node, and then we will return this leaf node. So this is when we reach the stopping condition. Okay, so if we reach the stopping condition, then we will be creating a leaf node. Okay, so using this create node method, okay, so we'll create a leaf node, and then we will assign the majority class label as the class label of this leaf node, and then we will return this leaf node. So this create node function, see, it is going to create a new node, or it will be extending a decision tree by creating a new node. Okay, so here see the node in the decision tree, see, as I said, see, it can be either a test condition. Okay, so just like For example, in the previous examples, we have considered the annual income. Okay, so then see sometimes the gender. Okay, so all these are test conditions. So this leaf, so this node, it can be either a test condition or it can be a leaf node. Okay, so this create node will be used to create a new node here. Okay, so say this will be executing, or this steps will be executed whenever all the records they belong to the same class, or if you reach the stopping condition. Suppose if you have not reached the stopping condition, say stopping condition will not be reached whenever the training record contains records that belong to multiple class levels. If you have got records that belong to multiple class levels, see at that time, see we will be creating a root node first. See, we will be creating a root node using this create node function. And next thing is we need to find the best that is split here. That is, we need to choose one of the attribute as a splitting condition here, or splitting attribute. So for that we are calling the find best split. Okay, and for that we are passing the attributes as E and F. So this function find best split, so it is going to determine which attribute we must choose as a splitting attribute, or the test condition for splitting the training records. Okay, so again, see, in order for deciding the best that is training attribute as a splitting attribute here, or the test condition, we can use the impurity measures like entropy, Gini index, and then that is classification error. So these measures can be used, and using the values of the measures, we can choose one of the attribute as a best splitting condition. Okay, so this find best split is used to determine the best, that is attribute, to split the training records here. Okay, so we will be choosing the best split, or the best attribute to split the records here based on the impurity measures like entropy, Gini index, and the and one more is classification error. Okay, so once we choose the best splitting attribute, then we will be assigning that as a test condition of the root, and then say based on the outcome we will be dividing the records here, so whether they belong to the right hand side subtree, or they belong to the left hand side subtree. That is based on the values of this that is test condition. So test condition, it will be having either two values or three values. So based on that we will be dividing the records here. So for each of these values, see, again we will be creating that is a path here. Okay, so we'll create a path for each of these attribute value. Okay, so or the test condition value, that is for each of v that belongs to v. So for that we will be creating a path here by using that ev is equal to e, such that root test condition of e is equal to v and e belongs to e. So for example, say in case of that is homeowner, see we had two, that is partitions or two subtrees here based on whether the attribute value is yes or no. So like that, see here we will be having many, that is paths for or splitting for each of the attribute values. For each of these attribute values, so we'll be creating that is one of the path here. So that path we have considered as EV. Okay, so EV is equal to E such that root dot test condition of E. So this value, it is equal to this attribute value, and this E belongs to the set of training records here. Okay, so that is we have found the path or the number of records that belong to each of the path here. So again all of those records or the path, they will be having see records that belong to more than one class. So again, in order to choose the next that is a test condition, or in order to stop the tree growing process, we need to call this function tree growth. So tree growth of, so again the parameter here is that is set of records that belong to this that is attribute value v. So ev will be passing, and then f is the attribute set here. Okay, so that we will be passing, and we'll be creating a child node here. So that child node will be again containing a test condition only. So this child node will be added as a descendant or child of this root node, and we will be creating a edge here, that is from root to this child. Okay, so as b, so if we create the that is child node for the left subtree, so in the same way we'll be creating a child node for the right subtree also, that is based on the attribute value. So again we need to call the same function, that is tree growth, in order to grow the tree. Okay, so this is a recursive function. Okay, so here what we have done is, so initially, see we had that is for in the first step we need to check whether all the records they are satisfying a stopping condition. Okay, so or they belong to the same class level. See, if all the records, if they belong to the same class level, so at that time, so it means that we need to create a leaf node and then assign all the records to that leaf node. Okay, so that is class level will be assigned as the majority class level, and that will be considered as a leaf node. This is when we have reached a stopping condition. Okay, suppose if you have not reached a stopping condition, so at that time, so we will be creating a root node. So in the first step, by choosing one of the attribute as a that is test condition. So we'll be choosing one of the attribute as a test condition, or we'll be finding the best split out of these f attributes here, that will be chosen as a best split, and then we will be assigning that to the root test condition. Okay, so again this test condition will be having many values here. For each of these values we need to create a path here, or we need to split the records. So for each of these values, so we'll be creating or partitioning the records here, that is as EV. So for each of the values, for example, in case of the previous example, homeowner, we had two attribute values, that is yes or no. So for that yes or no, we had divided the attributes. So in the same way, if there are V values, so we need to create a path for each of these values, that is EV, that will be containing a set of records here such that the root dot test condition is E, that is equal to V, and this E sets of records that belong to the capital, that is set training records. So once we create the path, next again we need to grow the tree by calling this same function, that is tree growth. Okay, so we'll call the same function with this value, that is, or with this sets of attributes here, EV comma F. So once we call this function, it will again choose one of the attribute as a test condition. Again, it will divide the attributes into purer subsets. So like this, it will be growing until we reach the stopping condition. That is, until all the records, they belong to the same class level. Okay, so this is the procedure that we'll be following in case of decision tree algorithm. Okay. So now, so next topic, so better we will discuss in the next class. Okay, suppose if you got any doubts, you can ask.